Good evening, everybody. This video that I am recording for your request is for exponential and logarithmic functions, part 2. Alright, before I get started, there's a few things that we have to address. I know you guys have been given a lot of work to do. I know it's like, oh my god, it's too much to do. And then how it's acting towards you guys in terms of not, telling you if your answer is right or wrong. I can't do that because, in the sense of learning from what mathematics is about, you guys going to learn how to stand on your own to figure things out and be confident within your skill. I know for a fact no one don't likes to be wrong. One thing for a fact that I have taught you guys, that I hope that you guys have learned from me, it's alright to make mistakes, because look, I make them. And sometimes I make them on purpose in class just to get you to feel comfortable in making those mistakes, because that's how you grow. One of you students caught on to what I was doing. It was very impressive. But I need for the rest of you guys to be alright with it. I know, nah, it's wrong, blah, blah, blah. And whatever teachers you have had with you, I promise you guys, if you just try and be okay with making mistakes, I promise you, it's going to get a whole lot easier. Because those mistakes, you learn from them and you become better off. Take it from someone with personal experience to that. Alright. This is what I would not do in these videos or in any form of tutoring. I won't give you answers. I'm not doing that. I know some of you guys want me to give you answers to the problems I gave you. No, I did a few of them in the class. I think, you could, manage on your own. Alright? I'm not going to, hold your hand. You guys are big enough that you can walk on your own. So please be aware that I'm also would not allow you to come to any tutorings to get answers and slack off. That's not going to happen either. I know you guys, like to sit back and watch me just talk and do all this, that, and the third. That's stopped. If you can't come into the tutoring presenting something that you do know from it or having a conversation with me about stuff, I can't help you. I'm just going to throw you out in tutoring. Plain and simple. Also, I won't allow you to slack off in regard to test prep. So when we do our review before our test, I'm not playing with none of you guys. It's not to be happened today. I know some of you guys was like not being disruptive, and your grade will reflect that. Trust and believe. You're gonna catch in your grade book. Also, allow you to think that you're gonna pass the class while I do demonstrating the skill. If you don't got the skill that I need to see, can let you pass through the next math course. It won't happen. I know you guys are used to teachers passing you up, and then when you come to this far, you can't demonstrate the skill. We won't do that. Alright, let's move on. That's good, that math. That's good, that math. That's good, that math. So guys, that's just within my native language saying, what is math? Of course, it's right there for you. Mistakes allow thinking to happen. Guess what? That's actually on your test. So you must know that. And you must explain what it means for that. For math to be math. And you'll be like, okay, mistakes allow thinking to happen. What do you mean by that? You have to explain it. As I told you guys beforehand, I'm going to make mistakes and I'm going to keep making mistakes. Because I need for you guys to feel right. Oh, it's okay to make mistakes and grow. I know you have dealt with teachers who like making mistakes is a no-no. That's partially true. Because when you get to your test, you got to be perfect. But in order for you to get perfect, You have to make mistakes along the way. Because if you don't, and you're so concerned about being right on the first try, you're not going to never go nowhere. It doesn't matter what teacher you have. And I know how you got students think of, no. It gotta be right. I'm gonna do it, then my ass is right. Be confident in your skill. So you could bring something to the table and I could help you fix the mistake. I can't help you if you're not showing me what you got. So when you come ask me these questions, is this right? Please be aware that I'm not going to respond to you. Come to me. Okay, Miss Sarah, this is what I did on this problem. I did this, that, and the third. What do you think? That's the way that you gotta start talking to math teachers. Some, I'm gonna be honest with you, do not care. And, here for whatever they are here for. Unfortunately, I can't allow you to do that. And that's the reason why I'm spending part of this to lecture to you guys about what's going on. This one part definition, because there's 3 parts of definition of mathematics. This is the second one that I taught you guys. The third one is going to be on you, but we're going to talk about that later. But this is the one math definition and the only math definition on your test that I will put on there that you have to talk and explain clearly about it. All right, let's move on. All right, so you guys know the definition of an exponential function, with b being defined by what b have to be greater than 0, but it cannot be 1 either, and x is any real number. X is the exponent. All right, and we know that any transformation of y equals bx is also an exponential function. We know this, but this is what I want us to do. I want us to go back to our previous math skills to figure out what an exponential function should look like. All right. So guys, we got a function. We got this function. We have to determine if it's exponential. And of course, by looking at the definition, yes. But one thing that will be questioned on your test is like, okay, what about the definition? What it said, you have to go a little further than that. One of the things that I want you guys to be able to do this on your own merit. So, on your test, you're going to have to graph this by hand. Oh no, Mr. Allen, how am I going to graph this by hand? That's too much. So to do this, guys, let's take it all the way back. X. We're going to go all the way back. And Y. We're going to go ahead and plot our points. After we make our table, all right, 6 tables. 16s of tables. So guys, let's go ahead and use 0 for X. So what this is telling you, that for the X value being 0, I'll plug in 0 for the X. So guys, this P of X is pretty much just saying Y equals 2 to the power of X. That's all this is saying right here. So guys, 2 to the power of 0, what's the answer to that? Any base to the power of 0 is what? 1. Good job. So let's go plot it. 0 and 1. You know what? Maybe I should. I wish I could thicken this out somehow. I'm just going to draw a point that way. All right. Let's go ahead and move on. So guys, let's do 1. 2 to the power of 1 is what? Itself. So for 1, I get 2. For 1, I get 2. Alright. Let's go with 2. 2 to the power of 2. I know for a fact it's 4. Alright. Yeah, you have to forgive my shading because I'm trying to shade with this. Alright. I'm gonna put this on my table. Bam. Alright. Now let's move on. Let's get something to the negative power. So guys, suppose if I have negative 1, so if when I have negative 1, going back to our law of exponent, I know that anything to a negative power could be rewritten as a fraction. So that's just 1/2. So that's going to be negative 1 and negative 1/2. Why am I missing my point at 2, 4? Alright. And then let's just do one more just for fun. Oh, I see. So after you plot these points, and to be honest with you, 4 is good enough. Because you could see the graph. And my pen don't get right before I go on strike. Get right, pen, as I tell the students. So guys, and we could go further if we need to and see how this keep going. So let's go ahead and choose negative 2 then. Well, 2 to the negative 2 power, that's just 1/4. So if you notice something, let me erase that and write that a little bit better. Again, I'm sorry about my handwriting. I'm trying to get used to this new technology I got, or this new pen, and it kind of got a mind of its own because it's tripping a little bit. So you notice when we get to the smaller numbers, or you call the bigger negative numbers, you notice it keeps shrinking as a fraction, it keeps going smaller and smaller and smaller. But you realize as you keep going in terms of negative numbers, it's not going to never reach 0. Because guys, 2 to the negative 3rd power is 1/8. Again, it shrinks because it starts off, when we get to negative 1 power, we get 1/2. And we know that 1/2 is 0.5. And then when we get to 1/4, we get to 0.25. And then when we get to 1/8, that is, I believe, 1/12. I mean, 0.12, I believe. Double check my skills. Oh, I was missing one. So it's 0.125. So it keeps getting smaller, and you could keep going on and on and on and on, but it's not going to ever get to zero. So we know that that's an exponential function. So we got that figured out. All right. So with that being said, before we continue, this is a basic exponential function. So let's talk about all its characteristics while we got the information up. So I'm going to erase the table. I'm going to erase the scratch work and leave the table there. And let's go ahead and put the things together. Characteristics. So the domain. The domain of an exponential function is what? All day, every day. All real numbers. Notice I'm running the R? Bam. Alright? So the range. The range, let me go ahead and do this because I know some of you guys are struggling with the range. So where I start at, so I'm going from down to up. I keep going, I keep going, I keep going, I keep going. And my graph, I start off getting very close to zero. So I have to include that there. 0. Because that's when the graphs start, essentially touching. It's not like an actual 0, but it's like a dangerous close 0. So that's why we include 0 to it. Because the graph start at some very, very, very small number. Close to 0, but not at 0. So as we keep going up, guess what? The graph never stops. It keeps going. So I'm always looking at my y values. So 0 to infinity. Alright, I'm sorry, I should have wrote that in purple. So that's my range. My domains are real numbers. My range is 0 to infinity. Domain range. What else are we looking for? Because I have domain are real numbers and the range of 0, I have a horizontal asymptote because of that range. Remember, the range tells me something about my horizontal asymptote. Remember, the range tells me something about my horizontal asymptote. The range tells me something about my horizontal asymptote. The range tells me about something about my horizontal asymptote, which is 0. The range tells me something about my horizontal asymptote. Okay? So that's my horizontal asymptote. What else do I have? Because I have a horizontal asymptote and a range, because I have a horizontal asymptote and a range of 0, my y-intercept, you can write this as 0, 1, or y equals 1. Never, ever, 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 forever, ever, forever, ever, forever, ever have a vertical asymptote. I will never have a vertical asymptote because of my domain is all real numbers. Alright, so we just went over the characteristics of an exponential function, and we just proved why the base of an exponential function has to be greater than 1. So we're going to look at some cases next of what happens with the base equals 1, what happens when base is less than 1, what happens when the base is negative numbers. All right. Give me a second. You guys gonna have to forgive my music for a little bit, but I think we need a little bit of a focus, because I think that music is a little bit soothing, you know. All right, back to it. I just want you guys to kind of feel the soothing sounds. So let's do this. So we're gonna explore why the base of an exponential function cannot equal 1. So let's do it. Going back to our Algebra 1 days, y'all. You don't have decimals, and again on your test, I'm gonna have you do all this by hand. And for this one, of course I want you to state the definition to explain why, but I want you to go a little further. So let's do this. So let's go with 0. So guys, anything to the 0, any base to the 0 power is what? 1. So okay, we have it right there. So what about 1 to the first power? That's just 1. Okay. What about 2? The base is 1, the exponent got to be 2. 1 to the second power is just 1. So essentially, this becomes a constant. It becomes a straight line. Just like that, y'all. And again, that is the reason why that cannot be an exponential function, because it gives you a constant. So on your test, I would recommend for you to create some tables and go from there. Okay. Let's do this. Now, this is half. So, get your table on. Let's go ahead and do the situation. What I would do for you, if I recommend you guys, if you want to, try to create just 6 points on a graph. Do no more than 6. I would say 3. Only do less than 6 if you know that the graph is not going to be a function and you have to, explain it. All right, so let's try this. All right. So let's do 0. 0 is the easiest thing to do. I always start with 0 because 0 is fun. All right. 1/2 to the power 0. Anything to the 0 power is 1. All right. So let's use 1. So 1/2 to the first power is going to be 1/2. All right. Y'all excuse me for a fast second. I'm sorry. All right. Let's go for it. So 1 to the power of 1/2, well, equals 1/2. All right, so that's going to be this guy right here. And you're going to notice something. So what if I was to plug in 2 right here? Well, that becomes 1/4. What about 3? That becomes 1/8. And then 4 becomes 1/16. So it keeps shrinking, and it's going to keep getting closer to 0, but it's never going to touch. So 1, let me erase this. 2, 3, 4. So it gets closer and closer to 0, but never touches. And you know that's going to be my horizontal asymptote. But we know something about the graph. We know that it gets closer to 0 here. You notice how the other graph was going from the other side? So when we draw these points, well, before we draw these points, let's deal with some negative numbers so this could be easily seen. All right. So let's do -1. Let's see what happens. So this is going to be interesting. Why people bother me when I'm trying to go to work? So when you get -1, I'm sorry. All right, my phone shut off. So when you get to -1, your value is going to be just 2. How you get 2, Mr. Howard? Well, Susan, this is how you do it. So again, this 1/2 is already s and could be written as 2 to the negative first power already, times a -1 power. When you multiply those together, it becomes 2 to the power 1. All right, let's do -2 and let's call it quits. So here, when it's -2, it becomes +4. And you see how when you plan your points on the negative side of this, you get something that looks like this. Just like that. And guess what? Now we could draw the points. Oh no, that's one ugly graph, but you see the point. So guess what? Anytime you see a fraction, this is called an exponential decay. Or exponential decay. Because although it's less than 1, but it's not a negative number, you get that. And that's how you deal with that. So on your test, when I'm asking you to sketch these graphs, guess what? All you're doing is going back to Algebra 1. Math is building up on the fundamentals that you have previously been taught. So let me erase this and let's go over our characteristics right quick. So our domain is all real numbers all day, every day. My range is going to still be from 0. Let me draw my little arrows again. So again, for my range, I'm going from downwards to upwards. It started at some 0 number that came dangerous close. We don't know what this graph stops at in terms of that, but it get dangerous close to 0. So it starts from the 0, and then as you keep going up, it ends at some very, very large number. Infinity. Let me address this once more. So for the range, it's not going to be negative infinity because the range you think about is all the y values. So from negative y to positive y. The crazy thing is with this particular function, this graph is in the positives. Because it's above 0, it gets close to 0, but never touches. But it gets close, but never touches. Alright? But eventually, one of these days, in a lifetime, if we keep going and going and going, it's going to get to 0 at some point, but it's going to take it a hot minute. So we say, okay, well, it don't get past 0, so it got to be greater than 0, which is another way of saying 0 to infinity. So y has to be greater than 0. You can say greater than or equal to. Okay, it will touch 0 one day, but it's going to take forever. So most mathematicians want to say that y is has to be greater than 0. So leave this, because other than that, other mathematicians get sensitive. All right, and don't forget your domain is where it starts off with. This is in the negative x right here, because the graph is there, and ends in a positive infinity because the graph keeps going there. So you have arrows here and here that says negative infinity to positive infinity. All right. All right, let's look through this one. Now notice this one has a negative in the front of it. So I don't know how I feel about negatives. Negatives are kind of a little bit of a pain in the neck to deal with. So that negative is going to do something to our graph. it's going to affect the characteristic, if not some characteristics. So let's just see about it. So 1, 2, 3, 4. So guys, let me go ahead and start off with just 1. So -2 to the power of 1. That's going to be just -2. Alright, so let's go ahead and pick 2. So let me show you how to do a problem like this. So you don't have any parentheses, right? So because you have no parentheses, you're going to do this a little bit differently. So we know that 2 to the power of 2 is 4, but because you have a negative in front, you're going to bring that negative with you. And that's going to be -4. And going back to this is -2. Alright, so let's do one more. Let's do 3. So -2 to the power of 3, because it's not like this, it's going to give me -8. So let me ask you, these points that you see here, which quadrant all that's going to go to? 1, -2, 2, -4, and 3, -8. And that's somewhere over there. Alright. So let's go ahead and get 0 here. Now 0 is also going to act differently. Now we are accustomed to knowing that any base to the power of 0 is always going to be 1. In this case, it's going to be slightly different because you have that negative in front. And again, because you have that negative in front. So -2 to 0. Again, because you have no parentheses surrounding that 2 and having that 0 outside, that's going to give you just -1. Alright. And then if we was to go from -1, we get 0.1, we get 1/2 or 0.5 if you want to go there. And that's going to be right here. And if you go from some smaller negative numbers, it's going to actually just keep going. It's going to get close to 0, but never really touch it. And it's going to look like that. So we notice, then we came to this. Our domain stayed the same, because domains are real numbers. The range stays the same also. The thing that changes is this, is the y-intercept change. The y-intercept is 0, -1. Alright, boys and girls. This is the end of part 2 of exponentials and logarithms. We haven't got to the laws just yet, but well, we did in the first video of this, but this is just a good detail to kind of help you understand exponential functions. So the biggest takeaway here is that we took some algebra 1 skills, made ourselves a table to plot information on a graph, and we drew the shape they resemble, and that's essentially just it. And we use the definition of this, so that's pretty much just all you have to do, y'all. And again, just try, y'all. I know, I gotta be right. I gotta be right. Don't destroy that mentality. I know that's gonna be hard for you guys to erase because that's what you've been exposed to for so long. But I promise you guys, from what I know of it, many students who go to college with that mentality, they don't succeed in college because they don't know the sense of hard work and, working it through and persevering it. You guys are from Louisiana. One thing that Louisianans know how to do is persevere through some stuff. I mean, been through hurricanes, how COVID messed us up and how we still hanging in there. We've been through so much as Louisianans, but one thing we know how to do is persevere. And I'm going to leave you guys on this note, and I'm going to do another video posting, I guess, solving equations for a little bit. I think you guys kind of got the hang of it, but that's just going to be it.